Avogadro's number is one of the most important numbers in chemistry. Probably not the most, but it's a very, very important number in chemistry. And so what it is, Avogadro's number is 6.022 times 10 to the 23rd. And what that means is there are that many atoms in a mole of atoms, or that many molecules in a mole of molecules. And so we can use this number to figure out if we have a mole of a substance, how many individual atoms or how many different particles do we have within that substance. And so we're going to practice going back and forth using that number as our conversion factor in today's video. So let's pretend we have 5 moles of carbon. How many atoms of carbon do we have then? If we have 5 moles of it, how many atoms? And so what we're going to want to do is we're going to want to use Avogadro's number as our conversion factor. So the question is, does this go on top or bottom? And so what I like to remind myself is this stands for representative particles, meaning atoms, molecules, whatever word fits in that blank, per mole, okay? And per 1 mole, always 1, all right? So what that means is if we have moles of carbon on top, we're going to want moles of carbon on bottom. And on the top, we have 6.022 times 10 to the 23rd. And that'll be atoms, that's our representative particle, of carbon. And now we just do our math. 5 times 6.022 times 10 to the 23rd divided by 1 gives us 3.0. Remember those sig figs? They're going to be based on whatever number you start out with. 3.0 times 10 to the 24th atoms carbon. Do put the units. You got to have a number plus a unit in any measurement. And in this case, it's atoms. The number one place I see students going wrong is they forget to put their units in every part of the equation, and then they get really confused at the end because they don't know what they just turned their number into. So use your units and let them guide you. All right, so now we have figured out that there are 3.0 times 10 to the 24th atoms and 5 moles of carbon. Okay, let's do another one. Let's start out with 3.0 moles of sulfuric acid. So with sulfuric acid, it's the same way. We're going from moles, but instead of going to atoms, it's not an atom, we're going to molecules. All right, it's the same thing. 1 mole goes on the bottom, and 6.022 times 10 to the 23rd molecules of H2SO4 goes on top. Then you do your math. 3 times 6.02 times 10 to the 23rd gives us 1.8 times 10 to the 24th molecules of H2SO4, sulfuric acid. All right? And so in these cases, we've gone from moles to molecules using our conversion factor. But what if we want to go the opposite direction? Same principles apply. So let's start out with 4.35 times 10 to the 22nd molecules of H2O. If this is what we're starting with now, we're already starting with molecules, and we need to get it to moles. And you might be like, why do I care if it's in moles? Well, once we have it in moles, we're able to get it to more useful things such as grams, which we'll be covering in a future video. But right now, we have to get it to moles before we can get it to grams. And so if we know we have that many little bitty molecules of water, how many moles is it going to take up? Or how many, what amount of moles do we have? Same principles apply. Except for in this case, we have molecules on top. That's our representative particle. So representative particles goes on the bottom. So that is 6.022 times 10 to the 23rd molecules of water in any 1 mole of water. Multiply together, so 4.35 times 10 to the 22nd times 1, you don't have to put that in your calculator obviously, divided by 6.022 times 10 to the 23rd. This is where I see a lot of calculator errors, because if you just type it in like that, 4.35 times 10 to the 22nd times divided by 6.022 times 10 to the 23rd, it put parentheses around this and you'll always end up with the wrong number. Okay, so use that EE button on your calculator in lieu of times 10 to the 22nd, and then you won't have to use parentheses. If you don't use the EE button and you use times 10 to the 20 whatever, then you're gonna need those parentheses, or else it will make a please do excuse my dear Aunt Sally mistake. Okay, those order of operations. So type that in your calculator and you should get 0.0722 moles of water. So once again, molecules is canceling on the bottom, moles is what's left, so that becomes our units on our answer. We just multiplied these two numbers, this times 1 over this, give us our final answer. Sig figs, 3 sig figs here, 3 sig figs here. Let's do one last one. So we're going to start out on our next one with 6.72 times 10 to the 24th atoms of iron. So in our conversion factor, our representative particles goes on the bottom, and that is going to be atoms of iron, and on the top, 1 mole of iron. Same principles apply. Multiply these together. This divided by that gives me 11.2 moles of iron. And now I know how to convert from moles to atoms, moles to molecules, or molecules to moles, atoms to moles. And that is simply through a conversion factor which uses Avogadro's number.